Hi there, Andy here. So let's talk about some special cases of electron configurations. Special cases. So the first one, which you have a high chance of seeing if you're tested at this at all, are excited electrons. So what do we mean by this? Let's take a simple example. Let's say boron, or actually let's say beryllium. So beryllium, which is, so we have protons equals 4, neutrons equals 9 minus 4 is 5, but we don't really care about the neutrons. And let's draw the electron configuration of beryllium. 1s2 and 2s2. So it has a complete orbital. Now, let's draw this out. 1s. Let's draw out the electrons. So 1, 2, 3, 4. Okay. So when we're talking about excited electrons, we have our atom in the center. This is the nucleus. And then we have the orbitals around it in the different shells. And let's draw the electrons we have here. We have 2 electrons there, and then 2 on the outside. When we talk about excited electrons, we basically have energy coming in, hitting one of these electrons, and popping it out into a new energy level. This is a good way to conceptualize it. So normally after 2s2 we would have 2p6, right, with 3 different orbitals. But in this case they're not full because there are not enough electrons in beryllium. But if we put energy into beryllium, what could happen is that this electron can pop over here. And now we have 1s, 2s, 2p. Now we have an electron, 2 separate electrons. And so the energy is used to pop that electron into a different energy level. And so how would we write this? We would say 1s2 to s1 to p1. So when you're looking through problems on the MCAT, if you see an orbital that isn't filled, something strange like 2s1 and then something, then it continues on, that probably means that the electron has been excited and that there's energy in the atom. So be sure to keep that in mind. Additionally, think about this. At some point, this electron is going to go back to its ground state. And when it does, it emits light, or energy, really, in the form of light. Sometimes. In lights. Let's just say that. And so this leads us to discussions on kind of the different types of emission and absorption spectrums, which we'll talk about in a future episode, which are quite interesting to know and just something that can be tested on the MCAT for sure. So that's going to be a different video. We're just talking about special cases of electron configurations here. So keep in mind that those electrons can get excited. The second case is something you should know about. It's an exception that may be tested on the MCAT, it may not, but that's the case of the D block elements. What do we mean by D block? Well, you should already have a good idea of what a periodic table looks like. Let me see if I can get this to a proper size. So you should know that, oh, where did it go? You should know that on over your left is S, and then the middle is D, and your far right is P. So in the D block, we have special rules, as we know that D can have up to 10 electrons, so D10. So this is kind of written as D with 5 different orbitals. D block elements will prefer to fill these orbitals at the expense of an S orbital. So maybe doing an example would help me explain what that means. So let's say we have, I'm going to write an electron configuration. I'll do argon. I'm using the shorthand notation. And then 4s2, 3d4. Okay, so what element is this? We have argon and then 6 elements after that. 1, 2, 3, 4, 5, 6. This would be what? Chromium. Now, this structure would never happen. Why? Because there will only be one electron here, and that second electron will go into the d orbital, make this 5. So it basically fills this orbital. So what you can see is that d block elements, let's write this down, it's an important note, d block prefers half filled or completely filled d orbitals. So let's look at the same case with another example. So we had one where it was half filled. Let's look at one that's completely filled. So again, I'll use the shorthand for argon. We'll do 4s2, 3d9. Which one is this? So this is 11 elements after argon. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is what? Did you guys find it on your periodic table? Do you guys find it? It's copper. And so again, this would never happen because the d block element will want to fill up the d orbital. So instead, let me rewrite that. Instead, it'll be 4s1, 3d10. And when we're talking about valence electrons are those electrons on the outer orbital of an element or an atom that can react. This entire thing is composed of valence electrons. So any of these can react with other substances. So just keep that in mind. That's a huge topic, is no electrons really inside argon would react because they're all, paired up with each other in their different orbitals and subshells, but these 11 electrons definitely can react, as copper does so much. So you can see that the trend is to fill these half or full orbitals. So if you look at your periodic table, you should be able to find some of these. So chromium, rubidium, copper, and silver are kind of the main four that will exhibit this trend. Now this is pretty specific for the MCAT, but it's definitely something that could be explicitly asked, but also just the idea that you know about these valence electrons and that half-filled things can be more stable can give you kind of this implicit knowledge that you might be able to use to answer other questions.